But
That's
run the
my
numbers
opinion.
though. You know, run the numbers.
Well, what the numbers have to do? I mean, it's things. If you're on a ball, everything away from you should be at a different angle than you.
Well,
Right.
here's the thing. Sorry, I'd like to chime in one
Sure.
second. All right. Now, when you're looking across the water at objects at a distance, and when you know, whether it's a globe earth or a flat earther, and they state, well, when you can't see it, that's because of atmospheric effect or whatever. But when you do see it, well, the idea for the globe earthers is saying it's refraction. Well, the thing is, some days where they say, well, it's not refraction, it's no matter what, how you're viewing it, it's always, I mean, let's think of it this way. We say lean away, right? If we're looking at something that's as parallel as possible. But the thing is, when we rise in elevation, we don't see the. I mean, we see things. I don't know how you say it. We still don't see it lean away from further distances that we see. Like
Yeah.
if you're on a plane and the furthest thing you see in the distance, you don't see this lean away occurring.
Right. But the question is, how much lean away do you expect? Like that's because, you know, the thing is, I always tell people, you know, trust your senses, but you can't you can't measure the weight of an eyelash. If someone drops an eyelash in your hand, you can't feel that weight. So it's like, no, I don't say reject your senses. I'm just saying if there's something that is so small that you can't perceive it, then that doesn't mean it doesn't exist. I mean, the eyelash is sitting there in your hand. And so I'm not saying the eyelash doesn't have any weight. I'm just saying you can't feel it. It's so tiny. So this lean away, how much lean away do you expect? Like what would be visually, you know, apparent to you? And I would think it would be a lean away of like 30 degrees or, you know, 45 degrees. A great example, and I hope you guys get this. If you walk up to a 4-story building and the 4-story building is right in front of you, if you were to draw the diagram, if you're like even 3 blocks away, the top of the building is further away from you than the bottom, the front door of the building at eye level. So it's like, but you don't say the building is leaning away. The building is vertical, but the top of the building is further away from you. You know, so that's the whole thing of lean away is really.
You're talking vertically though.
Yes, I am, but you don't say, oh, that building looks like it's leaning away from me, even though technically, from your vantage point, it is. The top of the building is further away from you than the bottom. That is leaning, even though physically it's vertical. I mean, physically they build the building.
The lean would be noticed to the left or to the right. It wouldn't be noticed straight up.
Yeah, but no,
you're standing exactly underneath it. But if it was leaning slightly to the left or the right, it would be noticeable.
Yes. So you wouldn't see it lean to the left or the right. And I don't think anyone's saying that, like on the globe Earth, if you had telephone poles that, you know, a L away is going to be leaning to the left or the right. They're expecting the telephone to be leaning away from you, you know, because it's going around the curve. But I say by how much, you know, a telephone pole a mile away, that'll be, you know, 1 arc minute of angle, which,
but if you were building towers a mile apart, each successive tower would have to be raised on its front edge to be horizontal with the previous tower.
Yeah, well, no, they build
or also you're just building an arc. You're talking if you want a straight line between the towers.
Sure. I mean, and they talk about this when they build, you know, super long like suspension bridges. You know, the Verrazano. They say the Verrazano Narrows towers are leaning apart at the top, and I never believe any of that stuff because that's not the way they build stuff. But because where you are, if you're building one tower of the Verrazano Narrows bridge, it's plumb. You know, you have a plumb bob, and then you're building the other tower, it's plumb. You're not taking a tape measure between the tops of the towers. Like that's completely irrelevant.
Hey, can I jump in just real quick?
Sure.
Can I get a mic check on Scott? Scott, are you there?
Check 1, check 2.
Okay. All right. Thanks, Scott. Welcome to the show.
Can you hear me now?
I hear you.
Yeah, I didn't even know.
Yeah.
What's the guy's name? That's so. There's a guy that believes that we're on a spinning ball, right? I'm not trying to make fun of anyone. I'm just asking, right?
Yeah, I don't believe we live on a spinning ball. I believe we live on a planet that is orbiting the sun.
Okay, like a ball shape, though, right? I'm just.
Yes,
I didn't know.
It's more like a basketball than a pizza. Yes.
More like a basketball than a pizza. Okay.
Yes.
Well, I don't think it's a pizza, but that's fine. But I have a question for you. Do you think that most I'm not. It's not just. I'm not trying to. I don't like to. I'm intrigued by people that like to prove that we live on a basketball type thing. You know what I mean? Because I'm really
Yes.
interested in it. Like through. How do you explain? I'm just wondering, like how, sonar works under the water, right? Like with if I'm going to
Mhm.
shoot sonar under the water and there's there's a curvature, right? How would that work? How would how would that work on the supposed radius of our planet,
my-
as you would call it?
I don't know anything about the effective range of sonar, so I'm not
Okay.
really a great person to ask. But refraction works underwater just like it works. So
You think that
obviously.
you think the sonar would bend over the curve?
I think it would refract downward, so you'd get a little bit of extra range. But this is not expertise, but it's a great topic. I think I'm going to go Google it, when we get done
Yeah,
here.
that's what I'm saying. I like to look into these kind of things. You know what I mean? Like because and then also, do you how the most of the air, like at an airport, like let's say the longest landing strip, right? You have a landing
Yes.
strip. You're gonna fly a plane, and then you're gonna land on it, right? Are most of them level, like according to like level, right? You don't level means,
Yeah.
right?
Yes.
Okay.
But they if you made it as flat as you could, it would follow the curvature of the Earth. But most
Do you
most
think
runways don't do that. If you ever look at a telephoto lens, like somebody from like 5 miles
Yeah.
away from the airport, zooming in on the runway, the runway looks like it's got hills and valleys in it. So you
Of
really,
course, there's going to be a little undulations. You would call it,
exactly.
undulations, right?
Whereas if the runway's a mile long, that those undulations, you can't notice them when you go to land. You think it's a
Yeah.
completely flat runway, but if you have a telephoto lens, I mean, there's this one airport where the runway looks like it's got a 30-degree bend in it, and it's like
Yeah,
it's just
yeah. But do you know
it's a trick of the eye.
Have you ever heard of a runway that's on, like, literally on the ocean? Have you ever heard of those? That are like
Yeah, well,
3 miles long?
There was one where they built a bridge. They extended the runway by building kind of a bridge across the,
Well,
sort
they
of
have-
extending it off into the water. But yes, I've heard of
Yeah,
it.
there's tons of them, right? So if the water was curving, so you think that they built that runway to land airplanes on the curve according to the water? You mean? Like,
Yeah,
you
well,
think that's how they do it?
Because at constant elevation is what we would say. Because the curvature of the Earth is negligible. I mean, literally, one end of the runway, if it's a 1 mile long runway, one
No,
end
it's
of the
not
runway
1
to
mile.
the other,
No, they're usually at least 2 miles long.
Okay. Let's take a 2 mile long runway.
Yeah.
Well, how much of a hump would you have in the middle if it followed the curvature of the Earth?
Well, that's the thing. If one side of it is at sea level, the other side would be approximately like 30 something feet.
No.
But you can see, yes.
No, the whole thing's at sea level. Let's say the whole thing's at sea level.
But that's what I'm saying. So if you're at one point on a ball, bro, and you go and you put a straight line across a ball, the other side, one of the sides has to be higher than the other if you're starting at sea level on one side. Think
Yeah,
about it
Think
about it, right?
That's not the way they build things. Like, you're talking about a runway that they build out into the bay, into the water.
Like,
The whole runway is at sea
in
level.
the middle of the water, in the middle
Right.
of the level sea level. How they call it, sea level.
Yes.
Yeah.
But
Mhm.
but here's the thing, and this gets to how much curvature would you expect if you have a 2 mile long runway. The math is 2 inches per mile squared for the sagitta, the hump height.
Yes.
So 2 inches per mile squared. That's 2 times 2 is 4. 4 times 2 is 8. You would have in 2 mile runway. You would have an 8-inch quote unquote hump in the middle.
No, that's not
And
how
then
it works.
like you would never see it. Pilots would never notice it.
You're not
you know.
you're not doing the math properly right there.
It's 2 inches per mile squared for the sagitta.
It's 2 inches per mile squared.
Yes. So if it's a 2 mile long runway, you square 2 miles, you get 2 miles squared is 4, and then you multiply that by 2 inches, and you get 8 inches. So the sagitta height is 8 inches for that runway. The whole
Yeah, and
runway is at sea level, but if you were to shoot a laser beam from one end of the runway to the other, you'd have a quote unquote hump. I say quote unquote because it's not really a hump.
So it would hit the hump and you wouldn't see it.
Well, no, like
right?
let's say you set up a laser that's 12 inches up on one end of the runway, and then you had a laser receiver 12 inches up on the other end of the runway, and you shot a laser 12 inches above the runway. the hump would be like 4 inches away at the middle.
Okay. Let me ask you a question. I have a friend, and I think Travis is in here. I think Travis knows who Dave Wide Awake is, right? Travis. Anyway, he can you can see over land and see lights from sea level, like literally 1 inch at 20 something miles. I think it's like 25 miles. And at 25 miles, how much curvature should there be?
Yeah, well,
right. Think about that, right?
Right. No,
but how would he see over land? I'm asking you, how do you see over land then?
Yeah,
how do you see over land in between you from that distance? How can you see from 1 inch over the water, right? You're at sea level, 1 inch, right? But how can you see over land in front of you and then see land behind it over a curve? You wouldn't, right?
Well, every time I've run those numbers, and literally, like, that was a big thing a couple of years ago. It was like the long distance, the long distance photography records, seeing a mountain 150 miles away. Every time I ran the numbers, and I've run the numbers for like these, water level sightings where you put the laser, right above the water or whatever. Every time I've run the numbers, the refraction is usually like a tenth of a degree to make that visibility possible, and a tenth of a degree is not a lot of bend.
I'm saying though, how do you see land? How do you see land that's level? Like I'm in Florida, for example. I'm telling you, in Florida, it's level, bro. I used to live there. It's literally all level, right?
Like sea
Florida,
level,
right? Florida is pretty much sea level. Yeah, like
it's pretty flat.
Some parts of Florida are under sea level, okay? Like where it would get flooded a lot, right? So what I'm telling you though is where you can see land that's at sea level beyond land that's in front of you 20 something miles away. How would you see that?
Yeah, all I'm saying is that
it bringing up I'm asking though, is it bringing up
a degree of refraction to make that possible?
You think
geometrically you're correct.
Wait, hold on,
happen.
just real quick. Don't try not to hand wave dismiss his question, because it's a lot more profound. It's not complicated. Hold on. It's a lot more profound of a question than simply defaulting to say that you can see it because of refraction. Because in order for that claim to be made, the data for that condition must exist, and you must have that data to appeal to. Otherwise, all you're doing right now is creating a possibility for which you have no validation or verification. So it's not just a matter of saying, well, it just takes a small amount of refraction. So here's what I would like. This is on my channel all the time, guys. Everybody here, everybody out there listening to the sultry sound of my voice, I say this all the time. When I read Andrew Thomas Young and he makes statements like severe refraction or minimal refraction or just a little bit, I'm sorry, sir. What and how is that quantified? Right? Because it's not in the documents. It's not there. So it's not just a matter of giving us the rhetoric of, oh, it just takes a little bit of refraction. No, sir. Not at all. I'm not going to let anyone get away with that. But right now I got to run and turn in my paperwork. Guys, keep it up. Thanks everybody for checking out the show, for being here. We've got John Sudlick is in the show. Ebon Kim is in the show. Pebble in the Pond. We've got Flat Earth Math, Charles here, and as well Scott. Guys, thanks so much for being a part of the show and making it happen. I got to step away. I'll be right back.
All right. Well, yeah. Well, I was just saying, like, I don't believe that a landmass can be refracted up. But I have a question though. Okay, you can say lasers, you can say light, you can say things bend in a certain way because of atmospheric conditions, right? What was your name again? I'm sorry.
It's Charles.
Charles. Yeah. I know that light can bend. Can seem visually like it's not bending, but it's visually looking like it's bending. But let me ask you a question. Above all that, because you guys are talking about buildings and how you know what a plumb bob is, right?
Yes.
A plumb. Like, you know, when you build a building, because I've built buildings and stuff like that, and I know what a plumb bob how it works, right? It will go down to the radius, like to the, I mean, sorry, it would go down to what you would call the radius of the ball that you think you live on, right?
It just points straight down. We'll just
perpendicular, perpendicular. It goes
vertical.
perpendicular to the ground, right?
Right.
Okay, so I've always thought about this, like, because you know how there are ways of measuring distances, right, at long distances, right?
Yes.
Okay, so let's say we had a Sears tower, just as hypothetical, but it's very possible you could do this. You have a Sears tower next to a Sears tower that is 5 miles away, right? Let's just go 5 miles, right?
Yes.
And you measure the distance between the bottom of the Sears tower, the first one, to the bottom of the one that's 5 miles away, and then you measure the bottom of the top of the Sears tower to the other one, right? Do you think that those would be different?
Yes.
So you think have you ever seen that proven?
No, because it's a ridiculous it's a
No,
ridiculous
is that
thing.
ridiculous?
Is
it ridiculous?
No, but
No, it's not though.
No. It's a good question.
They have things that can measure. You can, dude. They have. There's ways of measuring distances.
Yes.
Right, and then so if you have 1,000-foot tall building, the top of that building, I can almost guarantee you. I can't guarantee it, but I can tell you they wouldn't work because, like you guys are talking about like the leaning thing, it wouldn't work, dude.
The lean away. Well,
yeah.
Then the question is, how much distance would you expect if the Earth were a globe?
That's the question. Well, according to the mathematics of the spherical equation, it would be, and of course, it would at a 5 mile distance, it would be very small. But you know, you can measure things at a very small rates. So very small, you know.
A theory.
We have like a Leaning Tower of Pisa situation.
That would be a very small amount. You know, you have these two towers 5 miles apart, and they're,
of course, 5 miles is not very far.
Right. But they're quote unquote leaning away at the top. But
yeah.
By how much? You know, a couple millimeters. You know, an inch. I mean, who's going to notice that the tops are an inch apart? You know.
Well, who's going to notice? You know how there's very minute. I mean, dude, there's ways of doing that.
Oh, sure. And if you did it, it would be a very interesting experiment. I would love to see something like that. But that's not what I lead with when I'm trying to convince people, you know, about the shape of the Earth. I don't lean. I don't lead.
I don't know your background. Are you trying to convince people that we're on a globe? Is that
okay?
Because I'm not trying to convince anyone of anything. I'm just asking questions. By the way,
I would love for people to discover the truth of our world. Let's put it that way. And so, because my channel, not nothing, but it has a whole ton of DIY experiments. And I don't know if you heard my conversation with Travis. He's looking at the Belt of Orion. And
yeah. We were talking about that actually. Yeah, it's very intriguing, but I'm not sure exactly, where he's going with it.
Yeah, well, the thing is, like, if you just looked at the Belt of Orion, and like I said, it's December, everyone should be able to see Orion. Orion's high in the sky in the winter, the winter sky. I don't know if you're in the northern hemisphere.
Yep.
Okay, so if you were to find when Orion is due south of you, and you were to measure the angle of elevation to Orion, that's going to match 90 degrees minus your latitude. I don't know what latitude you're in, but I just made a prediction. Like, I don't know you. I don't know where you live.
Oh,
but
you're
I
saying
can tell
like
you,
you're saying that no matter what, it'll be 90 degrees latitude from where you are, no matter what, right?
Minus your latitude. Is correct.
Yeah.
It's like, well, how do I know
saying,
that?
Are you saying that proves you're saying that somehow proves a globe? I mean,
no,
a globe thing?
It's consistent. It's consistent with a globe, and you cannot make the same measurement on a flat Earth. Because
I know what you're saying, by the way, because believe me, bro, I don't believe in the circle AE map thing. Okay. I don't believe in that. As far as like, I haven't seen proof of it, right?
Yeah.
But you can't the thing is though, I'm pretty sure. Can you prove that that an ocean curves? Can you prove that to me? That an ocean curves?
Well, my emphasis is on the shape of the Earth, and like once you figure out the shape of the Earth, well then you answered your own question. But water looks flat, Water looks flat.
Yeah, water looks flat because I'm pretty sure it is. You know what I mean?
Well, so So
pretty positive.
me arguing that this flat-looking water is actually curved, it's not going to convince anybody. So I don't lead with that either.
Hold on now. Hold on. I'm going to try to be as fair and equitable as possible, as well as trying to be